Okay, so in this section, we're talking about 1.4, which is dealing with real numbers and the number line. So there's some terms we need to know here. The first one is integers. Okay, we mentioned this before. So basically, like -2, -1, 0, 1, 2, those are integers. So basically, they include the natural numbers and their opposite as well as zero. Okay, so those are integers. Rational numbers, as I mentioned before, one way to represent rational numbers is in fraction form. Okay, so that's a part of it. So P over Q, and here it says P and Q cannot equal zero. Okay, all right. So I'm sorry, Q cannot equal zero because you can't divide by zero. All right, so P can be zero, but just Q can't. All right, so again, the some of the fractions can be like 1 over 2, 128 over 6 or 1/4, anything like that, right? Those are all um, rational numbers in fraction form. The integers, we just talked about that. That's the numbers above here, right? Those are the integers. And then all repeating. So if you think about it, all repeating means, if I take 1 divided by 3 in a calculator, if I put that in a calculator, you'll see it'll say zero point 0.3 forever, right? It goes 0.33333. So that's what it means by repeating, okay? So this is 0.3. And to represent it, something is repeating, we put a bar over that number to indicate that number just keeps on going forever, okay? All right. So that is what I mean by repeating. And then terminating decimals. So for example, if I take 1/4, right? 1 divided by 4, another way to write that is 0.25. So notice that it terminates. It's not like the previous one where it's repeating. The answer is just 0.25. Okay. All right. So that's what they mean by terminating decimal. The next one we have here are irrational numbers. Okay, so irrational numbers, if you think about them, one can be like pi, right? Pi is an irrational number, goes on for goes on forever, right? Another irrational number is like radical 2, right? Another number is radical 3. So there are plenty of irrational numbers, but those are some of them. Okay. Um, the next part here are real numbers. And real numbers is basically everything, all of the above. Okay. So all the above. All the above. Okay, that constitutes the real numbers. So it can be irrational numbers, it can be a rational number, it can be an integer, any of those combinations, okay, is a real number. Okay, so the next term we have is average, and I'm sure you heard that before. Right, so if we have numbers, say two, make a different color. Say we have numbers 2, 6, and 10. All right, so let's say we have these three numbers here. We want to find the average of those. So we just add those numbers. So 2 plus 6 plus 10 and divide it by the item numbers that we have. So that we have three items here. So For the top, we get 18 and then divided by 3, which gives us 6. Okay. So the average of this will be 6. The next one is a number line. I've talked about that already, but okay, so this is an example of a number line. Okay. Absolute value. So the formal definition of absolute value means the distance on the number line from the origin. Okay. So let's say that I wanted to take, well, we know, for example, say 2, right? The absolute value of 2 is 2. And then if I put -2 in there, the absolute value of -2 is also 2. Okay? So it's saying here is the distance on the number line from the origin. So the origin, this is our origin here. Okay, this is our origin, right? So I wanted to take the absolute value of 2. Well, the distance from the origin is 2, right? So it's 2 away on the right side, and it's also 2 away from the left side. Okay, so that's why it's always positive. Whatever you put into that absolute value, it becomes positive because it's talking about the distance from 0. In this case, you'll always have 2 on this number line because 2 from the right side of 0 and 2 from the left side of 0. Okay, or I should say 1 from the right side of 0 and the other one from the left side of 0. Okay, so that's what they're talking about. We're talking about absolute value. Okay, and then inequality, right? Those are just your alligator symbols, right? Less than equal to, um, greater than, greater equal to, right? So that's what inequality means. Okay, so this next one we want to find the opposite of each expression. So what's A going to be? Minus -6. What's the opposite of that going to be? Good, right? It's just 6. Good. How about this one? We got -4/5. What's the opposite going to be? Well, what is negative times a negative? What will that be? It'll be a positive, right? Negative times a negative is a positive 4/5. But we want the opposite of that, right? So that would be what? -4/5. Okay. How about this next one here? We got 3 negatives now. Okay. All right. So we're getting some -4/5 or +4/5. Well, a negative divided by negative is going to give us a positive, right? A negative divided by negative is a positive. So we have the negative on the outside still, but here now it becomes just a +4/5 because again, we're doing it inside the parentheses first, right? So negative divided by negative is a positive, and then we have the negative, which is -4/5. Well, we want the opposite of that. So the answer is going to be 4/5. Okay, all right. All right, so this one we have what? Negative times a negative times a -2, which gives us a what? What's the opposite going to be? Hmm. All right, so again, we're getting split up again between negative and positive 2. Well, negative times a negative is a positive, and then positive times a negative is another negative. So we would get -2, right? But again, we want the opposite of that. So the opposite of that will be a +2. Okay, and then that's our answer. Okay. And then the last one, negative, negative, that's going to give us a positive b, and we just want the opposite of that, so that'll be a negative b. Okay, so let's look at the next one. It says classify the number as one or more of the following natural number, whole number, integer, or rational number. So it's saying we have a number here we need to identify. Is it one of these guys? Is it more than one? Or is it none of them? Okay, so -8. What do we know about what's that one? What's -8? It's an obvious one. So if we go back our notes, natural number starts with one forever. Okay. Not a negative number. So it's not a natural number. Is it a whole number? Is -8 a whole number? Good, right? -8 is not a whole number because remember, negative whole number starts with what number? Zero. Very good, right? So whole number starts with zero. Okay. So it's not a natural number. It's not a whole number. Is it an integer? Is -8 an integer? Yes, good, right? Oops. So -8 is an integer. So it is an integer, so let's check that. Is it a rational number? Is -8 a rational number? Okay, so we're getting mixed answers here. All right, so -8 is also a rational number. So remember, a -8, I can rewrite that as -8 over 1. Wouldn't you agree that -8 divided by 1 is the same thing as -8? Okay, and -8 over 1 is what? It's in fraction form, right? Another way to describe rationals by use that you can write it in fraction form. So yes, it's an integer and a rational number. Okay. All right. Now next one is -10 over 5. Well, we just said this is in rational form, right? It's in fraction form. So this has to be a rational number. Okay. So let me erase this here. Okay. So it is a rational number. Check. Okay. So this is a rational number. -10 over 5 is a rational number. Is it an integer? Is it an integer? Hmm. Hmm. If I simplified it, what do I get? What's -10 divided by 5? It's going to be -2, right? So -10 divided by 5 is -2. Is -2 an integer? Yes. So if -2 is an integer, then that means -10 over 5 is also an integer. Okay, so that's an integer. All right, and then we just mentioned that it's not a whole number. Can't be a whole number because it starts at 0, and this is -2, and it can't be a natural number because natural number starts at 1. So it's none of these guys. So this has to be an integer and a rational number. Okay, for both. Okay, so let's go through this. So the first one, pi. What is pi? Is that natural number, integer, rational number, or irrational number, or any of the combination? What do we get for pi? Irrational, good, right? So remember, irrational means you can't express it as a single fraction, right? It can't be represented as a single fraction. So irrational, so pi is irrational. Okay, how about radical 25? What about that one? What is it? Is it a natural number? Is radical 25 a natural number? Yeah, yeah, right. So nat radical 25 is a natural number, right? Because it's the same thing as 5, right? Radical 25 is the same thing as 5. So that's a natural number. Okay. Is it an integer? Yes, it is an integer. Is it rational? Yes, I can rewrite 5 as 5 over 1. So yes, it is rational. Is it irrational? Cannot be represented by a fraction, a single fraction. And that one is no, right? So it's not irrational. All right, so it's a natural, integer, and rational. Okay, next one, negative radical 3. Okay, so that's going to be irrational. Okay, negative 5, that's an integer. And rational. The next one, if it's repeating, that's a rational number. Number 3, well, that can be reduced to 1/3. I'm sorry, 9/3 is 3. So that'll be an integer, okay? Or a rational number, because again, I can write it as a fraction form. And natural number. All right, so for the next one, least to greatest, right? So the lowest number is going to be negative pi, the negative 3/16, negative 112, radical 7, 9, and 14. So that's going to go from least to greatest. Okay, so for this one, we want us to evaluate. So we have the absolute value of negative radical 2, the absolute value of 2/3 minus 1/3, the absolute value of 3 minus pi. And then the second part here says insert symbol greater than, less than, or equal to make statement true. Okay, so we got 3/5 is it's greater than, less than, equal to 0.6, negative 112, sorry, negative 110, negative 1/10 is that greater than, less than 0, or equal to 0. 4 is that greater than, less than, or equal to negative absolute value of -4. And then here we have if b is greater than 0 and a is less than 0, then what is the outcome? And this one, if a is greater than equal to b and b is greater than equal to a, then what is the outcome? And what's the relationship between a and b? All right, so let's go through this one. Okay, so we have the absolute value of negative radical 2. Okay, so that you should have just written radical 2, right? Or 1.41. Right, so again, that should have been radical 2 or about 1.41. 2/3 minus 1/3, that's easy. That's going to be just 1/3. The absolute value of 1/3 is still 1/3, right? And then 3 minus pi, another way to look at this, because if we do 3 minus pi, we're going to get a negative answer inside, right? So another way to write this is we can say pi minus 3. It's the same thing, right? Because again, we'll have a negative answer and then the absolute value is going to turn it to positive. Okay, so we should get pi minus 3, which is equal to 0.14159, etc. Right? Okay, and then this one here, we want to insert the symbol greater than, less than, or equal to. So 3/5 and 0.6 are those are the same, aren't they? 3 divided by 5 is 0.6, so these are equal. Negative 110 is less than 0. And then 4 and negative 4, that's going to be the same, right? Because the absolute value of negative 4 is positive 4, so these are equal. Okay. Now look at this one here. It says if B is greater than 0 and A is less than 0. Okay, so if B is greater than 0, say if we wanted to draw like a number line or something like that. Right, here's 0, and it's saying B is greater than 0, so B is here, and A is less than 0, so A is here. So that tells us that what? B is going to be bigger than A based off our diagram here. All right. The last one here says if A is greater than equal to B and B is greater than equal to A, that means A has to equal B in order for this to work. All right.